Welcome back to the channel. Today's video is on the graph of identity function. Identity function means y equals to x. So in this function, if we put a value in the domain, we will get the same value in the range. So if we put 1, the image of that 1 will be 1. Again, if we put 2, the image of that 2 will be 2, and similarly if we put any real number in the domain of the function, then we will get the same output in case of the identity function. So here we have this y equals to x. Now how to draw this y equals to x function? I will start by explaining a straight line. A straight line has this general form, which is y equals to mx plus c. Now, what is that m and what is that c? M is the slope of the straight line. Suppose if we draw a straight line like this here, in this case, if this straight line makes an angle theta with the positive direction of the x-axis, then m will be tan theta. So suppose if a straight line makes an angle 30 degree with the positive direction of x-axis, this is the x-axis and this one is the y-axis. So with positive direction of x-axis, if a straight line makes an angle 30 degree, then its slope will be tan 30. That means 1 by root 3. Now, so this is the m, and what is c? C is the y-intercept. So what is y-intercept? So in this straight line here, this is y equals to mx plus c. So this c is the y-intercept, meaning this length here. Okay. Now moving to the identity function, which is y equals to x, we can write it like this: y equals to 1 into x plus 0. So this one here, this one here is the slope of that straight line or the function, and this one here is the y-intercept. So y-intercept is 0, that means the function must pass through the point 0, y equals to 0 more specifically, or x equals to 0, as it is the y-intercept, and in this case the slope is 1. So what is the, which value of tan, which angle has the tan value 1? That is the 45 degree angle, or pi by 4. So here we have this formula. So the straight line or the identity function, which is y equals to x, must make an angle of 40 degree, 45 degree with the positive direction of the x-axis, which is this direction here, and it must cut y-axis at 0. So this is our straight line. This one here is the straight line y equals to x. Now moving to, we have drawn this function. Now if we move towards analyzing its properties, we can obviously see that y equals to x is a polynomial function. Moreover, it is an algebraic function. Okay. Now, what is the domain of that function? So domain of that function is R. Why R? Because in case of y equals to x, if we write like this, y equals to fx equals to x. So here it is the input of a function. So here we can put any value. Okay. So x belongs to R. Any real number can be put here, and also we are discussing about the real functions only, not considering any complex kind of function. So for real functions, this is the domain of this function is always R. And also we can see the identity function maps exactly the same as the input. So the output will be the same as the input. In this case, the range will also be the real number. Now, it is an increasing function. So from the graph here, we can see that this function, as we move from left side to the right side, so the value of that function is also increasing. Now, how can we prove a function is an increasing function or a decreasing function? We we find out the derivative of that function. So what happens if we do the derivative here? Y equals to fx equals to x. So if we do the derivative of this function with respect to x, we will get dy dx equals to 1. That is the derivative of x with respect to s, that will be 1. And this one here is always strictly positive. So if the derivative is strictly positive, then we can say that the function is a strictly increasing function. And if the derivative is strictly negative, in that case we can say that the function is a strictly decreasing function. And in case of if the derivative is greater or equals to 0, in that case we can say that the function is increasing function. And for the derivative being lesser or equals to 0, we can conclude that the function is a decreasing function. So in this case, as dy dx is greater than 0, so from here we can say that y equals to x is a strictly increasing function. This sign I will use for the strictly increasing function. Next is the odd function. So for odd function, we can say what happens, what property does the odd function satisfy? That is f of, okay, so that is for odd function we must have the property f of minus x equals to minus fx. Okay, so here we have, for the identity function, we have fx equals to x. So it can be easily seen that f of minus x, if we put minus x in place of x, we get minus x, and this will be from here minus fx. So this function obviously satisfies the odd function property. And what happens for the odd function is that odd function is symmetrical about the opposite quadrant. So that means this is the first quadrant, this one is the first quadrant, and this one is the third quadrant. So this function will be symmetric in the first and third quadrant because those two are the opposite quadrant. Next, the function is continuous on R, which is the set of real number. So why is the function continuous on R? From this graphical approach, from this graph here, we can see that we can draw this function without keeping our pen above from the page. So this is the, from this way we can say that. Also we can check it by using the definition of continuity. So for definition of continuity, suppose we have here a from a real point. So for continuity, a be an arbitrary real number. So for checking the continuity of f at that point a, we must have limit x tends to a fx equals to fa. Now let me check for the identity function. It is limit x tends to a. In place of fx, we can write x as that is the identity function. So we have a. And also as fx equals to x, this is the identity function. So if we put a here, we will get the output a. So this is fa. Okay. So this one here is the limit x tends to a fx. So as this condition is satisfied, so we can say that f is continuous, or the identity function is continuous at an arbitrary real number. So it holds for any real number. Next, for differentiability. So for differentiability, we can see from the graph, if the graph has no sharp edge, then the function is differentiable at that point. Also, for y equals to x function, there is no sharp edge in the graph. So the function must be differentiable at R. So again, we can prove it. Suppose we have an arbitrary function like this, arbitrary real number like this, a belongs to R. What we need to check? We need to check if limit x tends to a, fx minus fa divided by x minus a exists or not. If this limit exists, then we can say that the function is differentiable. So from here, for the, of course, identity function, which is fx equals to x, this limit will be limit x tends to a, x minus fa will be a. So these two will get cancelled out, and we have limit x tends to a, 1, so 1. So this limit exists, so we can say that the function is differentiable on R. Moreover, the derivative of this function will be 1, and we can see, we can conclude it from the formula that the derivative of the function x is always 1. Okay, so I have completed the identity function, which is y equals to x. In the next video, I will be discussing about y equals to x square. That is, if the power of x is increased by 1 from the identity function. Thank you for watching. Please subscribe to my YouTube channel and keep watching my videos. Thank you.